The question 12 is graphing reciprocal functions. Here they have asked us to find the excluded values. The excluded values are the values which make the denominator 0. That's it. So what you need to do is see when is x equal to 0. Here there's nothing, so x is equal to 0 when it's 0 itself, right? So this is excluded. We cannot consider this. Why? Because if you have this 5 divided by 0, it's undefined. It becomes infinity, right? It's undefined basically. Now what about this one? X plus 2 when it is equal to 0, that's not allowed, okay? So you can see x is not equal to minus 2 basically. This goes to the other side, it's minus 2. So excluded value here is when x is minus 2. Or you can write should not be equal to minus 2. That's the answers. And similarly over here you can do them by yourselves. This will be positive 3 and over here it is 0. Why? Because it's multiplication, right? To the other side it will become 0. And over here it'll be negative 3 by 2. See, you should just write as it is equal to 0. Take this to the other side, it'll be 2x equals minus 3, x equals negative 3 by 2. Same way over here, it'll be 9 by 7 positive. That's the answers. Those are the values which x cannot be equal to, so they are called excluded value. Now here they're asking us to graph. Now, since this is in the choice part, that is multiple choice questions, right? You will have 4 graphs. You just have to select the correct one. But before that, let me tell you a few things about the asymptotes. You need to look into whatever is being added or subtracted. If you see values added to it like plus 2, then that will dictate the horizontal asymptote. Horizontal asymptote. I'll just write ASYMP. Then what is the vertical asymptote? That is the excluded value. So whatever is x minus 1 equal to 0, right? X is equal to 1. So this is the vertical asymptote. That means in the graph at 1, there will be a dotted line. The graphs can come very, very close over here, but it can never touch this line. It will come close, but it will not touch. So that's the thing. Intercepts, whichever touches the axes. Let's look into this. See over here, undefined value is 1. So that is the point where there is vertical asymptote. So see, the vertical asymptote is x is equal to 1. Domain is all possible values except this value. That's it. X cannot be equal to 1 because that's excluded. And then we can see the asymptotes, the intercepts in the graph here. You can see this is the graph. One thing for sure we can tell is this asymptote at 1 vertical. Now here you can see there is nothing added to it. It's plus 0. So horizontal asymptote is at 0. And if there is any other number, it will jump up or down. Now, is it touching anywhere in the axis? No, the intercept is minus 1. But how would you know the graph? So you would easily know the vertical asymptotes, the horizontal asymptotes, right? Let's see over here at 0 and minus 1. Now you can choose any point and check it from this graph. Here the equation is there, right? You can easily find the correct graph using your calculator. Let us write this given equation here. 1 divided by x minus 1. Now you calculate, you will have 4 graphs, isn't it? Let's calculate at 0 and check what is the value. It's minus 1. Maybe 2 graphs will have it minus 1. You can easily eliminate the other wrong options. At 0, x is 0 I considered. The graph is at minus 1. Yes, this is correct. Let's choose other point. Let's take, say, x is 5. It's 1/4. Is it correct? 0.25. 1, 2, 3, 4, 5. It's, yeah, very close to 0.25. That's not so accurate, right? So let me take x of 1. It should be undefined. Yes, it's math error. It's undefined. What about 2? 2, you can see it's 1. Is it true? Yes, at 2 it's 1. You can check any value. Only one correct graph matches and that will be your correct answer. So you don't need to do anything. If you want to find the intercepts, you can substitute over here to find x-intercept, substitute y as 0. And then take it to the other side, it will be error, okay? Whereas y-intercept, when you put x as 0, you can get the answer 1. Minus 1, because minus 1 by minus 1. But otherwise, you can just check which is the graph and choose the intercepts as well. You can find the intercepts over here. So there are various ways. You don't need to do the table. Just look into the calculate, use your calculator and look at the graphs. Now here you can see the vertical asymptote is at 0 because denominator is only x, but horizontal is at +4. So you can see this graph, it will be having +4. See, 1, 2, 3, 4. That is the horizontal asymptote. Vertical asymptote is 0. Why? Because it's divided by x. Now then, for the remaining values, just type it in the calculator. All you do is minus 1 divided by x plus 4. Calculate it at 0 and check it's undefined. Yes, let's calculate it at say 1. It's 3. Is it true? 1, 2, 3. Yes. Let's calculate it at 4. It should be, sorry, the answer is, it's 3.75. Yes, you can put -1, -2, any values, and you will get the correct graph. You can easily match and get it. There is no y-intercepts over here. There is x-intercept over here at 0.25. That's how we can easily figure it out. Here there is no vertical, there is vertical asymptote at -4, but there's no horizontal asymptote. You can see the graph here. There is no, there's horizontal asymptote at 0 because there's nothing added, right? And vertical asymptote at -4. Sorry, there is horizontal and vertical all the time for reciprocal functions, no matter what. But here, if nothing is added, it's at 0. Whereas if there's anything added, it moves. And that's it. That's how we can easily figure this out. Even this one over here, it is at -3. Can you see? -2, -3. Somewhere over here is the horizontal asymptote, vertical asymptote as 0. And you can see the intercepts easily from the calculator. You can get the graph. Now we have a real world problem. A plane is scheduled to leave Dallas for an 800-mile flight to Chicago's O'Hare Airport. However, the departure is delayed for 2 hours. If t is equal to 0 represents the scheduled departure time, write a function that represents the plane's average speed r. Average speed, the speed is given as r on the vertical axis as the function of travel time t, which is based on the travel from the scheduled departure time to the destination. Graph the function. Okay, basically what we do is we need to know the formula for speed. What is speed given as? Distance by time, isn't it? So here, what is the distance? Distance we already know is 800. What is the time? Your time is delayed by how many hours? 2 hours. When you take it this inside, it will be t minus 2. So we write it as t minus 2. Because over here t is supposed to be at 0, but it's delayed of 2 hours. So, t, which is based on the travel from the scheduled departure time. Okay. This is delay. So when we have to equate it over here, when we get it inside, it will be 0. So this is the equation. Now all we need to do is we need to graph this up. Here +0, that means there is no horizontal asymptote. The vertical asymptote is +2. Now if you graph it, look over here, you can practically understand. That's this distance 800 t minus 2. So when t minus 2 is there, what is the asymptote at 2? So we can understand there cannot be anything at this particular point because that's where it starts. And then the graph over here at the right side, after this you can get the proper speed only at the positive axis, right? Because it's speed, distance, it cannot be negative. This is wrong. So after 2 hours, right? So now this is the consideration graph. And yes, it's in the positive axis. So this is the correct part. If you are taken other way around, if you are taken this +2, then it'll be at negative time, which doesn't make sense. Okay. So remember, what is the departure? If it was phi, it will be t equals phi. So it will be t minus phi basically. The asymptote will be at phi. That's how you would solve this. And you can just make a smooth curve. You can, get the table from your calculator as well. But since you will be given graphs, just put this equation in your calculator and solve it up. All you need to do is type it out. 800 divided by, that's x is for t minus 2, and calculate. Say at 0, what is the value? You will get minus 400. Yes. And let's take some, at 4, it's 400, is it? Yes. You can easily check the correct graph. Analyze the key features. So what is the domain? Domain is like, first you can tell the vertical asymptote is at 2. There is horizontal asymptote at 0. And what next? There's no intercept, but there is y-intercept at minus 400. Then what else they want? You can tell the end behavior, what is happening, and which is the positive scale, which is the positive graph. It's greater than t equals 2 and less than t equal to its negative part. So all that basic things you can just mention it over here. But since it's the electronic part, you can easily see the graph. And I don't think so this will be asked. Even if this is asked, you can easily get it from the equation. The next problem is again a real world problem about computers. To manufacture a specific model of computer, company pays 5,000 for rent and overhead 435 per computer for parts. Write a function relating to average cost. Okay, average cost will be equal to what? And how many computers n are being made? So over here, basically, the payment, whatever is paid, divided by n, I believe. Let me just check it over here. Yes, 5,000 by n plus 435. So what is the total amount over here? It's 5,000, right? Divided by n is the number of computers plus this one. So it's not like the last problem. There's delay which would have affected the time, but over here it is addition of 435, and just you have to graph this one. That's it. And over here, what will be the asymptote? The asymptote will be at 435. You can see somewhere over here is the asymptote, and you can see the values over here. You do not need to plot. You can directly figure out which is the correct graph just by choosing some points. Say over here, if you put 10, over here it will be some value of huge value. If it's 20, it will be nearly 700. So that's how we can easily figure out which is the correct graph. And what is the details of the graph over here we have, right? So we can just put that stuff like over here. What is the asymptote? I mean, asymptote is at 0. Vertical asymptote is 0. Horizontal asymptote is 435. There is an intercept over here at negative 10 or negative 11 or something. There is no y-intercept. So all these you can write. Where is the negative? Negative is less than n0 and more than n is positive, because obviously positive numbers will have positive over here because it's real world problem. So that's few things, few details of the graph. And then they have given us reciprocal functions. We have to graph them. These are pretty straightforward. We have done this just a while ago. This is horizontal asymptote. Over here, x is equal to minus 3 will be vertical asymptote. And then you can easily graph it up. You can see from here only you can analyze which is the correct graph. This will be minus 3. 1, 2, 3. Yes, at minus 3 there's horizontal asymptote. What is the vertical asymptote? Again at minus 3. 1, 2, 3. Yes, minus 3. And then you graph it. Then over here as well, you can easily see the asymptotes. Down 1, this is 5, means to the other side be minus 5. 1, 2, 3, 4, 5. Yeah, that's the asymptote. It doesn't touch the touch that line. Minus 6 over here. 1, 2, 3, 4, 5, 6 over here. Same way you can graph the others, guys, and you can see over here what's happening. The domain, basically, you cannot include the asymptote value. For range, you cannot include the horizontal asymptote value. That's it. All the graphs and details are over here. And that is the end of the question 12. Please use your calculators properly and you can easily solve these problems.